Welcome back. It's Saturday afternoon. Time to rest, time to relax. But at Canadian Competitive Math, since we are just 45 days away from the competition, we are not resting. We are still chugging on, and I'm giving all the information, all the problems that are needed for my students to face this challenge. Today, we are going to face one of the toughest problems I've seen in geometry. All the concepts that you have learned from grade 8 and above in geometry are tested today in one of the problems that I selected from previous tests. Hope you are ready for this challenge, and I will see you with the problem. Here we have a shape ABCED, and in that shape we have angle BAC as 24, angle BCA as 28 degrees. DC and AB are parallel, AD equal to BC. AE is parallel to BC, AB and CE are equal. O is intersection of DC, O is and AE. So from this we have to derive what is the angle ODE and angle OED. So the green ones that are here are not given in the question. I derived them at later point. Right. So what do we have here? Let us take triangle A, B and C. In triangle A, B and C, we have B, A and C, and we have B, C and A. So angle ABC will be equal to 180 minus 24 plus 28. So angle ABC is 128 degrees. For simplicity, I separated shape ABCD and shape ABCE. In shape A, B, C and D, we call this shape, AB is parallel to CD and AD equal to BC. We call this shape as isosceles trapezoid. In the shape BCEA, BC is parallel to AE and AB equal to CE. This shape also we call it as isosceles trapezoid. In isosceles trapezoid, since ABC angle is 128, angle DAB will also be 128 degrees. Since ABC is 128 degrees, angle BCE will also be 128 degrees. So from this we can see that using the principle of sum of a quadrilateral, we can find that angle AD and C will be 52 degrees, angle BC and D will be 52. Same is the case with other angles too. CEA and BAC are 52 degrees. Right. So if we take this quadrilateral DABC, we know that angle DC and B is 52. So this is 28. We can derive that 52 minus 28, angle A, C and D is 24 degrees. Similarly, we can derive that in the quadrilateral EA and B and C, angle EA and C. Angle EA and C is 28 degrees. We can derive that. Alright. Now, in the triangle OA and C, we have 28, 24. So this angle AO and C will be equal to 180 minus 28 plus 24, which will be equal to 128 degrees. Since AE and DC intersect at O, we have angle AOC as 128, angle EOD will also be 128. We can also derive that DO is 52 and EOC is 52. So we derived a lot of angles till now. I'll put it as a summary here. In this, We started with this rectangle, and based dependent on the principles I explained before, we can derive all these angles. We can derive that these two angles are 52, this is 76. Again, same is the case here, 52, 52, 76. I explained why these angles are 128, 128. These angles are 52 and 52. Right. From this we can see that triangle OAD and triangle OCE are similar because the angles 52, 52, 76 in this triangle, 52, 52, 76 in this triangle. So OD by OE, which is opposite to 76, is equal to AO by OC, which is opposite to 52 degrees. AO is opposite to 52, OC is opposite to 52. Similarly, triangle OAC and triangle BCA are similar. So AO by BC will be equal to OC by BA. From this we can derive that OE by OD, ratio of this OE by OD will be equal to OC by AO will be equal to BA by BC. See, earlier we didn't have any relation for this triangle ODE to any other triangles. Now, using these ratios, we related triangle EOD to triangle A, B and C. Right. So triangle ABC is equal to triangle DOE, similar. And we also know that this angle is 128, angle ABC is 128, and also angle DOE is 128. Right. And since we established they are similar, the angles ODE will be equal to angle AC and B, which is equal to angle O, D and E will be equal to angle AC and B will be equal to 28 degrees. Angle CAB will be equal to angle DEO equal to 24 degrees. So we started with two angles and some constraints, and we finally arrived at the angles that we need. This is a very complicated derivation, and I had to cover a lot of math principles here, principles of geometry, and I tried to explain and go in detail as much as I could. I suggest that you stop the video as many times as you need and follow this very carefully for you to understand. There are a lot of geometry principles I explained. They are important as you grow and as you go to engineering or you go to any STEM related field. These principles are important. So I suggest that you spend a lot of time, as much as you can understand, on this. In competition, this question will be given somewhere around 20 minutes to solve. And if we compare with some of the questions that we do at high school level in the classroom, this is highly complicated than what we see there, and that is for a reason. So these universities that are conducting tests expect people to be much more capable than just simple high school math that we teach at a high school level. And that's the reason I suggest all the students to get exposed to advanced math from middle school to high school level. That prepares them very well for the later part of their career, later part of their studies. Hope you enjoyed this, and if you have any questions, please put them in the comment below. And I also request that if you like my content and if it is adding any help to you, please like my content and subscribe to my content. Thank you.